Okay, so now we will discuss the NFA to DFA conversion. This is method 2. This method is also called as a direct method, right? So consider the state transition function which is shown here. So you can see it in the given table. So here you can see there are three states. Out of these three, Q0, Q1, Q2, Q1 and Q2 are acting as a final state, and Q0 is your initial state or a start state. And you have an input alphabet and it comprises two symbols, 0 and 1. The transition of initial state on input 0 is on state Q0 and Q1. Similarly, the transition of Q0 on input 1 is Q2. Transition of Q1 on input 0 is Q1, and it is same on input 1 also. Transition of Q2 on input symbol 0 is phi or empty set, there is no transition. And transition of Q2, state Q2 on input 1 is Q1, Q2. So this you can see here. Fine. Now, in this direct method, instead of considering all states in the power set of Q, only those states which are given are considered. Now, which are those given states? So now Q0, Q1, Q2, these are the singular states with whose transition you can see directly in your state transition function. But here you can see there are two states which are the combination states. We call this as a combination state. So Q0, Q1 is a state, and because it comprises more than one state, we call it as a combination state. So this is one combination state, and Q1, Q2 is another combination state. So from this state, we don't know the transitions on input symbol 0 and 1. So this we need to evaluate. So we'll consider this. So delta dash, as you know, delta dash, it is the state transition function for the resultant DFA, whereas delta is the state transition function of the NFA, right? So, so we'll compute the delta dash on this combination state Q0, Q1. So the input 0 and 1 is given to these states, and you could see from state Q0, Q1 on input 0, there is a transition on state Q0, Q1. Similarly, on input symbol 1, there is a transition from state Q0, Q1 on Q1, Q2. Okay, then there is another combination state Q1, Q2. So to this state also the input 0 and 1 is given, and you could see the transition is on Q1 and Q1, Q2, these states. Now, once these things are evaluated, you just have to check, is there any state which you got and which is new state? Do you got any new state or not? This you have to check. So after giving input 0 to state Q0, Q1, you are getting Q0, Q1. So this Q0, Q1 is already there in this transition function. So no worry. Now, after giving input 1 to Q0, Q1, you are getting the state Q1, Q2. Again, Q1, Q2 is also available here. Now, when you have given 0 and 1 input to Q1, Q2, you got Q1, this one state, and Q1, Q2, next state, respectively. So again, these two states, Q1 and Q1, Q2, you could see it is also available here in the transition function. So no worry, we didn't got any new state. But if you are getting some state here which is not available in the state transition function of NFA, then you have to consider that state as a new state in the resultant DFA, and you should give input to that newly found state also, right? So now in this case we don't got we didn't have any new state, so that agar yahan pe here if you are getting some state Q0, Q1, Q2, after I'm just saying, you just have to assume कि after giving 0 as a input to Q0, Q1, if you are getting Q0, Q1, Q2, So this Q0, Q1, Q2 is not a state in state transition function of NFA. So this state you got new state, and this state is it will belong to the resultant DFA. This newly found state Q0, Q1, Q2. It is not a part of NFA. It is a part of DFA. So to that newly found state, you should give input 0 and 1, and you should check what states you are getting. Again, if you are getting a new state, you should give again 0 and 1 input to the, and this you have to repeat till you are not getting any new states, right? So this is how it works, but there are advantages of this here. With this state, you will never get a disconnected transition graph, and you need not to compute the transitions for each and every state which are there in a power set of Q. So that is the reason it is called as a direct method also. So after applying this, so you got the state transition function for DFA. You can relate it with the one here. You can see Q0, Q1, Q2. For this, the transitions will remain same. So it is Q0, Q1, Q2, Q1, Q1, phi, and Q1, Q2. So here it is same Q0, Q1, Q2, Q1, Q1, phi, and Q1, Q2. Then for Q0, Q1 state and Q1, Q2 state, here you have computed this. So those things you can add in your state transition function of DFA. So these things are added. Now you can relabel it. One more thing I want you all to observe here. See here Q1, Q2, Q0, Q1, and Q1, Q2. All these states are marked as a final state. Now why it is so? Because in NFA, Q1 and Q2 are marked as a final state. So all those states which contains Q1 and or Q2 will be marked as a final state. So that is the reason here Q1, Q2 to mark as a final state, that is no issue. But in Q0, Q1, because this state contains Q1, so this is also marked as a final state. In Q1, Q2, again, both these states are acting as a final state in NFA. That is the reason here you have marked it as a final state. Then you relabeled it and you got this A, B, C, D, E. So here also B, C, D, E is marked as a final state. Okay, so these four states are marked as a final state. Exactly, Q0 is labeled as A, Q1 is labeled as B, Q2 is labeled as C, Q0, Q1 as D, and Q1, Q2 as E. And accordingly, their transitions are given here in the table. And depending upon these transitions, you could see from this table, we got this transition graph, and from this table, we got this transition graph. So this is how you can convert NFA to DFA using direct method.